introduction in the last video, let's check out how the entire operation on two-dimensional array goes. Before we step into the programming concepts of two-dimensional array, let's deal with some of the fundamentals which are going to be used regularly in every program of two-dimensional array. Before I start with any concept, I should understand how do I declare these two-dimensional array. So the declaration of two-dimensional array goes in this fashion. So the first fundamental is about the declaration. How do I do this declaration? We should always put the data type, then followed by an identifier, size 1 and size 2. The only difference when you compare this with one-dimensional array, in one-dimensional array we had only one size, and now we have two sizes associated. So I have an example as int a of 10, 20, float b of 50, 10. I can have a declaration as char c of say 10, 10. Not as that size 1 and size 2 has to be of different type, has to be of different values. No, you can have size 1 and size 2 as same value. You can have even a size 1 and size 2 with different values or same values. But they should be always integer constant. They should not be variables. There should not be any fractional constant. I can have a variable of type double also. So I'll say double p of say 10, 2. Not necessarily always size 1 has to be more than size 2. You can have even size 1 greater than size 2 or size 2 greater than size 1. So no correlation between size 1 and size 2 with respect to values. But the only constant is they had to be of type integer. Clear? Okay. Now question comes, how this memory allocation goes. Suppose if I have a declaration as say int m of 3, 3. We can visualize this as a matrix of 3 rows where the first row is 0, second row is 1, third row is 2, and 3 columns, that is 0, 1, 2. Now this is just for our visualization concept. But internally the matrix allocation or the memory allocation is not sequential. The memory allocation is total 9 location, each of 2 bytes. Let me put these locations for you and then write this number. So I'll have 9 locations altogether, 1, 2, 3, 1, 2, 3, 1, 2 and 3. So there are total 9 locations, each indicating 1 row. The memory allocation may be visualized as a matrix or a square matrix or a non-square matrix with rows and columns. But internally it will always go in sequence. Now when I say sequence, question comes, will there be a number associated with every sequence? Yes. All these locations may be held as m. This entire location is known as m. Now in that case, every location will be internally associated with some separate number. What will be the number associated with that? So the first location is m of. Now identify the index of this particular first number. First number has got an index as 0, 0. So m of 0, 0. Second location has an index as m of 0, 1. Third location has an index as m of 0, 2. Then fourth location as m of 1, 0. Next location is m of 1, 1. M of 2, 0. So here we were writing the indexes of these numbers. So let me continue with the index format. So here I'll have the first number as m of 0, 0, second number as m of 0, 1, third number as m of 0, 2. So 0, 0, 0, 1, 0, 2. Next is 1, 0, 1, 1, and this will be 1, 2. Now the next location will be m of 2, 0, m of 2, 1, and m of 2, 2. Now here we might visualize, we have visualized this as a matrix. But internally, it is not anything as such a matrix, it is a set of locations. Now based on this, we can conclude that each location can store one integer value. It means that I can store 9 integer values. So the total memory which is consumed by m is 18 bytes. How this is 18 bytes? Check this. So I have each location of 2 bytes. So 9 locations are there. So 9 into 2 is 18 bytes. So memory size of a two-dimensional array can be very easily calculated by multiplying size 1 into size 2. So the memory of this is indicated as memory. How do I calculate memory? Size 1, let me say S1, multiplied by size 2, let me say S2, multiplied by the number of bytes for one data. So now you have to tell me the size of these numbers. So multiply this. So I have size 1 as 10, size 2 as 20. So 10 multiplied by 20 is 2000, right? 2000 or 200. So it is 200. 200 multiplied by 2 is 400 bytes. So the total memory which is consumed by A is 400 bytes. Let me do this. B is 50 into 10. 50 into 10 is 500. 500 multiplied by 4 is 2000 bytes. So this is approximately 2000 bytes. This is 400 bytes. Now can you tell me how much size this particular C will have? Size 1 is what? 10. Size 2 is what? 10. 10 multiplied by 10 multiplied by the number of bytes for one data. How many bytes this character will have? 1 bytes. So 100 into 1 is 100 bytes. Similarly, can you tell me how this P, or how many bytes this P will have? Yes, you got it right. 10 multiplied by 2 is 20, multiplied by 8 is 160 bytes. So total memory consumed by this is 160 bytes. So we have to calculate the memory size as size 1 multiplied by size 2 multiplied by the number of bytes which are equals to one data, right? So we have declared and we have seen how memory allocation goes and how the values are going to be stored internally. Now based on this memory allocation, we can go ahead and say how the values are being read. Check this. So I have these indexes. So basically I tried to scanf for this, scanf for this, scanf for this, scanf for this, and I tried individual scanf for every location. Rather than writing a scanf for every individual location, what I can do is I can say this as M of ij. But this ij has to vary in a specific manner. Let's understand how these I and j vary. For that, what I'll do is I'll put the first index as I and the second index as a j. Now, the first three numbers, let's say this. In the first three numbers, I'll find that I is 0 and j is changing from 0, 1, 2. Next three, I is going to be 1 and j is going to go from 0, 1, 2. For the next three, your I is 2 and j is going to change from 0, 1, 2. So your I is fixed and j changes. But when I say fixed, it is not fixed permanently. It has to undergo change, but after every operation of j is completed. Once j completes, then you are supposed to go back to the next value of I. So the rotation or the movement of this particular I and j will always hint towards a for loop. To be precise, it is a nested for loop. How a nested for loop? I will be indicated by one for loop and j will be indicated by one more for loop. Check this. So I and j, which changes more regularly as compared to the other? Yes, you got it right. J changes more regularly as compared to I. The one which changes regularly is always the inner loop, and the one which changes least is always the outer loop. So here your outer loop is I loop and inner loop is j loop. Let's see how these values are written. So let me make you understand how the reading process of a two-dimensional array goes. Now here I have done it for 3 rows and 3 columns. So if I have 3 rows and 3 columns, the last index was 2 and the last index was 2 even with j also. But here if it is m rows and n columns, so m rows and n columns, then if I start from 0, the last row will be m minus 1, and if I start with n columns, the first value will be, the first column will be 0 and the last column will be n minus 1. So I'll write a for loop. So here the first loop which I have written is a row loop. So here row starts with 0, ends up at m minus 1. Column starts with 0 and again ends up at n minus 1. So this is my column loop. Depending upon what I do in this, it will be either a read operation or a display operation. If I say that I have used int a as a declaration, int a of say m and n, we can't write m and n, assume that m and n are some values, int m of or a of say 10 and 10. In that case, if I say scanf, this is going to read every element of an two-dimensional array. So I'm going to read when I is 0, j is 0, I'll read one element from the keyboard, that is from the user, and store into the a of 0, 0. When I go back, j becomes 1, so scanf will read the second element and store into a of 0, 1. When I go back, j becomes 2. The third element will be read as a of 0, 2. When I go back, j becomes false. When I go back further into I loop, I becomes 1. Then next is a of 1, 0, a of 1, 1, a of 1, 2, a of 2, 0, a of 2, 1, a of 2, 2. So if it is 3 rows and 3 columns, we can make this particular scanf to work for 9 times, and every time it stores a value at a different location. Similarly, if I have the elements to be displayed, the same for loop will be used, but here I am going to use a printf statement. A printf will automatically display the elements of a two-dimensional array. So it means that nested loop are the one which are used for all the operations of this particular two-dimensional array. The last fundamental which you are supposed to do is, can we initialize a two-dimensional array? Yes, I can initialize a two-dimensional array. So I can say, suppose if I have a declaration as int a of 3, 2. So I can set 6 elements at this place. So 3 plus 3, 6 elements in this fashion. The same declaration can be even rewritten in this fashion. I'll say int a of 3, 2 equal to 1 curly bracket. The same values, curly bracket, 12, 4, 6, curly bracket complete. And then one more curly bracket, 3, 1, 7, a curly bracket complete, a curly bracket. So here, the first set of elements indicate the elements of the first row. The second set of elements indicate the elements of the second row. You can either segregate them by indicating these curly brackets, or you can put them into these curly brackets. So basically, I can have this initialization not in the program, but at the time of the declaration itself. Similarly, if I have int a of empty square brackets and 3, the first square bracket can be kept as optional. If you are doing the initializations in the declaration, only the first bracket can be initialized. First bracket can be kept as empty, second bracket need to be initialized. So in that case, what I'll do is, I'll make a group of 3 elements each. Depending upon the number of groups which are going to be formed, the first number is identified. So 3, then 3, then 3. This is the first group, this is the second group, and this is the third group. So how many groups have been formed? 3 groups have been formed. So here the size is automatically calculated as 3, not by the user but by the compiler automatically. But do remember, only the first bracket can be kept as optional. If I have a deficit in any of the groups, those deficit elements will be automatically added as garbage values, depending upon the storage class. Suppose if I have only 7 elements, so if I make a group, the first will be a complete group, second will be a complete group, but the third group will be only 1 element. So in that case, those remaining elements can be taken as garbage values, or will be taken as garbage values. So the first bracket can be kept as optional. These are few fundamentals of two-dimensional array which you should remember before we proceed with the programs. The first is, how do I declare? Second, how memory calculation is done, how memory allocation is done internally, how do I read values, how do I display values, and how do I initialize this particular two-dimensional array. Go through these fundamentals properly before we start with the programs, because in the programs we'll be more concentrating on the logical stuff rather than these fundamentals. So make sure that you jotted down the entire contents properly. Have a complete go through before you start with the next video, because the next video will project the programs on this particular two-dimensional arrays. Thank you.